everyone, this is Dr. K. Jagannayaki, Professor in MBA Department, Institute of Aeronautical Engineering, Hyderabad. So today my lecture is on diagrammatical representation of data. So this is also one type of data analysis tool. So after completion of this session, the learner can be able to know what are the different types of diagrams and how to draw them without any difficulty. They can able to understand the relative merits and limitations of each type of diagram. Learners can make the most suitable choice of a diagram keeping in mind the given data set, and they can able to critically examine and interpret any diagrams and presentation. So coming to the diagrams, like graphs, the diagrams will also have visual impact on viewers' mind. So these diagrams basically categorized into four types: one-dimensional diagrams such as bar diagrams, two-dimensional diagrams such as rectangles and squares, three-dimensional diagrams like cubes, cylinders and spheres, and fourth one is pictograms and cartograms such as maps, etc. So coming to the one-dimensional diagrams, one-dimensional diagram means we used to consider only one parameter. So in that, when you are going to analyze only one single characteristic, and that can be known as one-dimensional diagram. So under which we have line diagram. This is one of the simplest form of diagram. So here we used to consider the height of each line. It indicates the value of an item that is being measured. The line diagram is drawn taking a suitable scale. So like graphs, here also we used to take a suitable scale, and then we are going to construct the line diagram. Then the second one is simple bar diagram. So simple bar diagram. So unlike the line diagram, a simple bar diagram shows a width or column. It is used to represent only one variable. Suppose if we have the production of an item X for 3 years, so each bar has an equal width but unequal length. So as we may have variation in terms of production for all the 3 years, the bar size will be equal. It will have equal width, but coming to the length, it may vary from 1 year to another year. The next, multiple bars. When two or more interrelated series of data are depicted by a bar diagram, then such a diagram is known as multiple bar diagram. For example, if you have the data related to export and import figures, and they can be displayed by two bars close to each other, one represents exports and other representing imports. So it should be noted that multiple bar diagrams are particularly suitable when comparison is involved. The next comes subdivided or component bar diagrams. So as the name itself implies that this diagram shows subdivisions of components in a single bar. For example, a bar diagram may show the composition of revenue expenditure of the Government of India. The components of this bar could be defense expenditure, interest payments, major subsidies, grants to states and union territories, and others. So in order to distinguish the different components, different colors or shades should be used. So this should be accompanied by a legend or key for identifying these components. So that's how we can able to show difference in terms of different components which we are going to mention in one single bar diagram. The next type is percentage subdivided bar diagrams. So these bar diagrams are useful when the relative changes in data are to be displayed. Suppose if we are given the following data pertaining to monthly expenditure of two families under some heads. So the items of expenditure about the two families that should be projected and that we can able to show in these two diagrams. The next type is broken bars. So in some cases, the data may have very wide variations in values in the sense that some values may be very large while others extremely small. So in such cases, larger bars may be broken to provide space for the smaller bars. So suppose we are given data relating to the number of students enrolled in certain faculties in a university. The data regarding the enrollment are given below. So here we have given arts 1500 students enrolled, science 2000 students enrolled, commerce 6800, management 500. So all these things we are going to project in terms of broken bar. The next one is deviation bar diagrams. So deviation bars are used to show both positive and negative values. So whenever we have given the data relating to rates of change in terms of percentage in agricultural production for a few years, so some cases we may have positive value, in some cases we'll have negative. So everything we can able to project in deviation bars, both positive and negative items. The next type is geodirectional bar diagram. A geodirectional bar diagrams indicates a diagram on both sides of the axis of x. One component is shown above the horizontal line, other shown below it. The two components taken together give the total value of the item displayed. The next diagram, sliding bar diagram. A sliding bar diagram is similar to the directional bar diagram. The only difference between these two is that the latter based on absolute values while the former based on percentages. So that is the only difference between directional bar diagram and sliding bar diagram. So sliding bar diagrams can be shown either way horizontally or vertically. It depends on the researcher how he want to project his data, vertically or horizontally using sliding bar diagrams. The next type is pyramid diagram. The pyramid diagram shows a number of horizontal bars which are arranged in such a manner as to give an appearance of a pyramid. So such diagrams are suitable to present data on population, occupation, education and so on. The next two-dimensional diagrams. In case of one-dimensional diagram, only one side, namely length of the bar is relevant to measure the magnitude of phenomena as we have seen earlier. So in contrast to one-dimensional diagrams, the two-dimensional diagram considers both length and breadth. So that is the area in rectangles and squares and the radius in circles. Thus, the three forms of such diagrams are rectangles, squares and circles fall under two-dimensional diagrams. The first one is rectangular diagram. So these diagrams are used to compare values of different items in two or more situations. The area of rectangular diagram is in proportion to the absolute value of a product or item. The next percentage rectangular diagram. So this is another type. So here we'll consider the absolute values of different items of expenditure, total cost, total revenue and profit. The same data on these items can be presented in the form of percentage rectangular diagrams. The next one is square diagrams. In a square diagram, the length and width are of the same dimension. So sometimes a square diagram is preferable to rectangle. This is because when a comparison is involved between any two phenomena but their magnitudes are widely different from each other. So it is difficult to draw rectangles on the same page. So one rectangle would have very wide width while the other very small. To avoid that, we'll prefer square diagrams. The next one is circular or pie diagrams. So this is another type of two-dimensional diagram which is more commonly used than square diagrams. So in fact, circles can completely or conveniently display the data on production of food grains presented in the preceding square diagrams. So first we have to calculate the degrees for each of the below mentioned items. The pie diagram is also known as an angular sector diagram, though in common usage the term pie diagram is used. So it is advisable to adapt some logical arrangement or pattern or sequence while laying out the sectors of a pie diagram or pie chart. So whatever data given, then we have to find out the angular angles and that should be projected in the circle, so which represent a pie diagram. The next type is three-dimensional diagrams. So three-dimensional diagrams are also known as volume diagrams. The common forms are cubes, cylinders and spheres. So in case of cubes, all the three dimensions, like we would like to include length, width and height together. And in case of a cylinder, the length and diameter of the circle are taken into consideration. In case of a sphere, the shape of a ball can be used in a three-dimensional form. The next type of diagrams are known as pictograms and cartograms. So pictograms are the pictures that are frequently used in presenting data as they are attractive and easy to understand and they are an appropriate mode of presentation of data, particularly for the layman. So in pictograms, the pictorial symbols are used to clearly indicate the item is what item you are going to display to the viewer. For example, if you are talking about the production of an automobiles over a period of time for the last 3 years, so that we can able to show in the form of the picture of cars. Whereas coming to cartograms, cartograms are used to present the statistical data and a geographical limits. So suppose we have to show the rate of literacy in different parts of India. Even if you want to highlight the water bodies that are available in India, so that can be shown by using maps. So cartograms are too very attractive, but they should be used especially where geographical comparisons are to be made and where approximate measures can serve the purpose. So this understandable as maps are unable to provide 100% accuracy. It may not be possible with cartograms. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.